Hello friends, welcome to my channel. Let's have a look at problem 2432, the employee that worked on the longest task. So this is a newly appeared problem and is an easy one marked by Leetcode. So first we're going to read through the statement and then we're going to write a linear solution for this problem. First, let's look at the statement. There are n employees, each with a unique ID from 0 to n-1. We are given a 2D integer array called logs, where the logs element is given by ID and leave time, where the ID is the ID of the employee that worked on the ith task, and the leave time is the time at which the employee finishes the ith task. All the values of leave time are unique. Notice that the ith task starts at the moment right after the i-1th task ends, and the 0 task starts at time 0. So we are required to return the ID of the employee that worked the task with the longest time. If there is a tie between the two or more employees, return the smallest ID among them. So this is actually an important requirement. So we want to return the smallest ID in the case of tie. So actually this problem, its logic is very simple. So we are not going to go into details for these three examples, but we want to look at the constraints. First, n is bounded below by 2 and bounded above by 500. The logs is also bounded below by 1 and above by 500. So all the others are basically consistency assumptions, and the leave times are sorted in a strictly increasing order. So with that said, actually we can go into the detail coding directly. So here the problem is actually very straightforward. So we could do linear scan of the logs and compute the work duration in the process and make comparison. The point to be aware of is that if there is a tie between two or more employees, we're going to return the smallest ID among them. So this actually determines how we do the comparison and do the update. So note that the leave time component forms an increasing sequence, while the employee ID component does not in the log, right? So that's the problem statement. Now let's look at the code. So because the task 0 starts on time 0, so we're going to initialize a start, indicating a start of a task. So initially 0, and then we're going to use a max duration. So we also set to be 0 at first, and employee ID. So I'm going to set it to be -1 at the very beginning. So with that said, so we're ready to do the linear scan. So here is a linear scan or linear traversal of the logs. So for this, we do not need to track the job ID. So we just need to check the employee ID and the end time, because we know the running starting time, so we can easily get the task duration. So we are going to use people. So for people and end time in logs, what we are going to do is to first compute the duration. So the duration is going to be end minus start. And we want to compare this duration with the running max duration, right? If duration is larger, strictly larger than max duration. So in this case, we're going to update the max duration to be duration. And also we want to update the employee ID to be the current people, the current employee. And then another case is that if duration equals the max duration, then we're going to check if the employee ID is less than the employee ID previous one. So if so, we're going to update employee ID to be the people. So in other words, we want to find the smallest ID when there is a tie, right? So this is a tie condition, right? So this is the update for this case. So after in each case, so when we look at a next task, we're going to ask to update the start to be the current end, right? Then what we're going to do is to return the employee ID, right? So this is actually the full code for this problem. So because it's an easy problem, we didn't do a walkthrough for a specific example. So now let's do the check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, I guess that's about it for this problem. Thank you.